Okay, this is physics, term 3, week 1. I hope, I think this is my first term 3 recording, considering from what I heard, the math is repeat. I think that's what I heard, and the chem also. If it is, welcome to term 3. I hope uh, this term is better than the last term, and inshallah, we put term 2 in the past, and everybody focuses on term 3. وانا I'm gonna try my best to from my side to help. المهم, that's enough talking. uh, for the material, it's chapter 5. This is easy, the pressure chapter, it was in the final. بس في kinetic molecular theory, okay, it's chapter 6. um, for the most part, it's very easy, and it's just PV equals nRT, and I'm sure you guys are all familiar with PV equals nRT from chemistry. فI don't think there should be any reason for me to re-explain it, بس أنا أكيد we're gonna solve questions. وكمان kinetic molecular theory, it has to do with there are some definitions you have to memorize to do with atoms. I'll go over that, and I'm gonna solve the quiz, then I'm gonna do these good questions. Some of them are old materials to do with saying chapter 3. المهم, let me start. I'll start with the quiz, but then I'll go to the course division. The difference between mercury levels is 12 centimeters. Always remember, you have to have that in meters, so this is 0.12 meters. Okay, use G equals 10, and the density 13600, and the atmospheric pressure 100. Okay, they're saying if the manometer is closed end, how much will the pressure be? Okay, remember, pressure equals rho GH, okay, in a closed end. Okay, however, if it's this is closed, if it was opened, it would be rho GH plus the pressure of the atmosphere. Why? Because it's opened. ف it's open, there's pressure coming from the atmosphere, and there's the liquid pressure. Okay, فالمهم, let's, whoa, why is that small? uh let me solve. uh Part A, if it's closed end, that means we're going to use rho gh, so we're just going to do the density rho 13600 times G, which is 10, times the height, which is 0.12. We said you can't use centimeters, so times 0.12, and you should get, yeah, and you get 16320. So this is pascals, yeah, but they want the answer in kPa. Okay, so that means you divide kilo, you divide by 1000. So let's divide this by 1000, and you get 16.32 kPa. Okay, and they want it to one decimal place, so just keep it as 16.3. Which is also correct if you take a look at the other answers, 16.3. Okay, then if it's open end, we said its pressure of the opened one is rho gh, so نفسها, it's the same rho gh plus the pressure of the atmosphere, atmospheric pressure. So we can just take this answer over here, 16.3. Let me put 0.3, and we can just add the atmospheric pressure, which is 100, which they're both kPa, so that's the only way you can add them. Okay, and you get 116.3, which is also an alternative answer over here, 116.3. Question 2, it's the hydraulic press. If you remember, you have a force and an area, and then they want the other force given the other area. Always, and the one I like to use, F1 over A1 equals F2 over A2, because remember, pressure equals force over perpendicular area, something like that, which was F over A. That's the important part. Always remember, F1 over A1 equals F2 over A2. This was in the final. Let me go a bit, I'll go a bit quicker. So 20 over, if they're both in centimeters squared, both of them, and if they're both centimeters squared, you don't have to convert. You can keep it 20 over 4 equals F2 over 50 and solve. So in this case, you don't have to convert. But if one of them was meter squared, one of them was centimeter squared, then you have to convert the unit from meter squared to centimeter squared. You multiply by 10,000. If you're going from centimeter squared to meter squared, you divide by 10,000. المهم, 4 times F2, 20 times 50, 1,000 equals 4 F2 divided by 4, F2 equals 250 newtons. Question 3, okay. If a liquid is open to the atmosphere, then أكيد there's atmospheric pressure. It's basic. I don't think I have to. المهم, question 4, what's the pressure at point B? It's pay attention, they're saying open to the atmosphere, yeah? If it's opened, always remember the pressure is equal to, of any open thing, is rho gh plus atmospheric pressure, because you have atmospheric pressure acting and you also have the liquid pressure. So let's solve it. So the pressure here would be rho, the density, which is 10 to the power of 3, okay, times g, which is 9.8, times the height, which is 12 centimeters, which is 0.12 meters, uh, plus atmospheric pressure, which is, where is atmospheric pressure? 10 to the power of 5. So just put this in a calculator and you should get, I don't think you get it in scientific notation. Uh, yeah, I don't think you get it in scientific notation. But if you, once you put it in scientific notation, you get 1.01 times 10 to the power of 5. Uh, Question 5. Which statements describe atmospheric pressure? أكيد atmospheric pressure is not always constant. It's different with the weather. Difference in pressure causes the winds to blow and rain to flow. The reason why it rains, one of the reasons why it rains and why we get wind is because of pressure. So أكيد is correct. Atmospheric pressure is affected by weather. أكيد. Changes in temperature do not affect atmospheric pressure. Of course not. One way I can prove this, just so you can understand, remember PV equals nRT. Okay, so obviously when temperature is changing, there is something to do with the change in pressure. Okay, you're gonna use that later, obviously, but I wanted to bring it up. Changes in temperature cause air masses to expand or contract, affecting the pressure. Yes, again, because PV equals nRT. Once the temperature changes, the volume of it will change, which will cause it either to expand or to contract and become smaller, which again affects the pressure. Okay, just I'm trying to help you understand. So if you don't want to memorize, okay, a fixed amount of gas is kept in a rigid vessel. The initial temperature of the gas is 300 Kelvin, and its pressure is 280 kPa. If the pressure of the gas drops to 180, what's going to be the temperature? Okay, look, there's two ways to do this, okay? We could do the chemistry way we used to do, which is P1V1 equals nRT1, or P2V2 equals nRT2. Okay, two ways. We can obviously cancel R with R. Since we're saying it's a fixed amount of gas, the moles don't change, so N with N. And since we're saying it's kept it in a rigid vessel, we didn't really talk about volume, but you can cancel volume with volume. You get P1 over P2 equals T1 over T2. Okay, you can use this, or if you want to go by the book, you can directly do. There is a law in the book which says somewhere here, somewhere here, yeah, P1 over T1 equals P2 over T2. This works. This is the same thing, by the way. But let's go by the way we were taught in chemistry, so it's a bit more familiar. So pressure 1 is 280, pressure 2 is 180, temperature 1. Remember, temperature always has to be in Kelvin, or 300 over T2. You cross multiply, and you should get 193. My fault. You get 192.85, and if you round that to one decimal place, I got 192.9. I think that's what I put. Yeah, 192.9. If you round it to one decimal place, I don't know why they're saying one decimal place and they're putting one. المهم, question 7. Uh, this is where okay, well, the last question was actually where it started, but this is where it starts to get, well, physics now gets really theoretical, and well, I'm mentioning this because we're gonna do it like this week. It's I'm recording this in the break, but we're gonna do this in like next week, and some of it, it's, bro, this is, we took some of this, isotopes, atomic number, mass number, we all took this, but it gets theoretical. You're gonna start seeing physics that doesn't really involve numbers. That's for next week. Let's stay let's stay here. Right now, this they're starting to introduce you to theoretical physics, and theoretical physics, you have to understand. You can't really memorize. Sorry. Uh, the tiniest particle of matter, everybody knows it's an atom. And I think the next one, okay, no, I think the next one is Brownian motion. Yeah, it's okay. Question 8. A fixed amount of gas is kept at a constant pressure. Okay, the initial temperature is 300, and its volume is 2 liters. The volume of the gas decreases to 1.2 and its temperature becomes 180. Again, you can apply V1 over V2 equals T1 over T2. That's the book. بس يعني I'm gonna show you the way we were always doing. T1 V1 equals nRT1, and then P2 V2 equals nRT2. Let's cancel moles with moles since they didn't mention it. R with R always. They're saying constant pressure, so we cancel P with P. So you get V1 over V2 equals T1 over T2. V1 is 2, V2 is 1.2, T1 is 300. We want T2. You cross multiply equals. You cross multiply. You should get F2 is. Do you get 180? Yeah, you get 180. Type question 9. Brownian motion is the motion of small chunks of matter, as can be seen under a microscope. Okay, I think it's a good question, so I'm gonna explain it. Uh, yeah, question 7. Okay, look. I'm gonna show you what. This is a basic overview. When we're speaking in physics, okay, this is a container. Okay, it contains, let's say, smoke. Okay, let's say smoke. This is the smoke clouds. You know how there's smoke particles? They're in clouds, right? So scientists they wanted to study the motion of particles. Obviously, the first thing they would look at is the atoms, right? They would zoom in into the atoms. And then they called the movement of atoms, they called it molecular motion. Okay? They figured out, atoms, they do move, and they called it molecular motion. But when they were asked to prove this, they said, we don't really have a proof. The idea of molecular motion was kept completely theoretical. Okay? It's theoretical and it's imaginary. Okay? That's what molecular motion is. However, they did come up with another type of motion, and they didn't really look at the atoms would be, I should draw black dots. So the atoms would be these black dots. So they were too small, okay? They're too small, right? So that's why they're too small. That's why it became theoretical, because they couldn't prove it. They couldn't really zoom into the atom. The atom was too small. However, they zoomed out a bit, and then they started looking at the actual smoke particles, the big ones, okay? And they said, oh, well, this moves. So they invented a term for that, and they called it Brownian motion. I think it has to do with the guy who discovered it. That's why they called it Brownian. So Brownian motion. Brownian motion says that these particles, the big particles, the smoke particles, move in a random motion, okay? But the molecular motion says that the atoms, so the actual atoms, so you zoom in, those move. But this is fake, okay? It exists, but we call it's imaginary, it's theoretical. However, Brownian motion is proved, and you can see it if you actually examine smoke using a microscope. You can see this Brownian motion. No, that's just an overview of it. They invented molecular motion as like a kind of a proof to the Brownian motion. They said smoke particles move because the actual atoms of it move. They said, why do atoms move? They said because of molecular motion. They said prove it. They said we can't. That's why they kept it theoretical. Okay, that's no, just a quick overview. I know it's not in the quiz, but it is in the material and the grid questions which we're gonna solve, and I guarantee they're gonna come. So don't neglect them. Please make sure you do that. How long is this recording? Okay, 14. That's good. That's good. It's not bad. Okay, let me continue. Question 10. The plunger sticks to the... Wait, and I didn't do question 9. How can we see the Brownian motion? We said you can use a microscope. And we don't really have any means other than a microscope yet. So that's why we can't really see the atoms, how the atoms move. The microscope is kind of like the furthest we have right now. So maybe in the future. Maybe in the future, molecular motion will not be theoretical anymore and it will be real. Okay, I'm yapping too much. The plunger sticks to the surface of the floor, obviously because of atmospheric pressure. Once it actually sticks, there's going to be atmospheric pressure from outside sticking onto it. Okay, and that atmospheric is way greater than than the pressure that's actually inside. You've got this question many times before. Question 11. When a vacuumized tube of radius 1 centimeter is placed, so this is A, it's radius 1, the liquid rises to a height of 800. So this is a height of 800 millimeters. Okay, if another vacuumized tube B of radius 2 is placed, how much is the height going to be? Obviously, it's going to be 800, and I showed you this before. I think it was another CA. I explained that no matter what tube you put in, the liquid will always rise to the same height. If the pressure changes, that's when the height changes. But if it's at the same pressure, since it's the same bucket of mercury, it's going to have the same height. So 800. Question 12. A fixed amount of gas kept at a constant temperature has an initial volume of 3 and a pressure 120. If the volume is increased to 4, the pressure becomes how much? Okay, again, PV equals nRT, P1 V1 equals nRT 1, P2 V2 equals nRT 2. R with R and with N always, since yani, in physics, well, you won't really use N. Okay, and since we're saying constant temperature, T with T. What do you get? P1 V1, since there's nothing here, you just take the equal sign down here. So P1 V1 equals P2 V2. So pressure 1 times V1, so 3 times 120 equals P2 V2. For 4 times, we don't know about the pressure, 4 times P2. For 3 times 120, 360 equals 4P2, and you get P2 equals 90. And obviously it's going to be kPa. Since yani, this is kPa, so this is also going to be kPa. Question 13. What happens to the potential energy of the molecules between 0 minute and 1 minute? Okay, I'm going to explain heating cooling curves quickly. It's very, very simple. Just focus, please. Okay, start, you go up, straight, go up, straight. Okay, let's call this A, B, C, D. Okay, and this is going to be temperature, and this is going to be time. Okay, 1 minute, 2 minute, 3 minute. Okay, here's going to be 10, 50, I don't know. So hold up, 50, here 80, I don't know. Look, I'm going to be very, very, very basic with you. If you want to understand, the first thing you should have, no, the rule you should have, when temperature increases, kinetic energy increases. And I think if you do bio, you know this. If you do chemistry, you should know this. Everybody should know this. If temperature increases, there's going to be more movement, so there's going to be more kinetic energy. So you're going to look here. You have potential energy and you have kinetic energy. Okay? When one changes, the other stays constant. You can't have both of them changing at the same time. Okay? That's the way I memorized. So from A, you're going from 0 degrees up to 40 degrees. What's happening in A? Temperature is increasing. So what's happening? Kinetic energy is increasing. So kinetic energy in A is increasing. And we said only one of them can change. The other one has to stay constant. So if the kinetic energy is changing, that means the potential energy isn't changing. For the potential energy in this case is constant. Okay, let's take a look at B. B, the temperature isn't changing. So the kinetic energy, since the temperature is not changing, the kinetic energy is constant. Okay, if kinetic energy isn't changing, that means potential energy is going to change, since one of them has to change. So potential energy, in this case, will change. Increase or decrease, well, it's heating. The temperature is going up, so obviously potential energy is it's increasing. In this case, okay, temperature did not increase, but we're going, and you look at the curve. You're always going up. It's a heating curve, so we're going up. Okay, how about C? Again, temperature is increasing. You went from 40 to, I don't know, 70. Okay, temperature is increasing, therefore kinetic energy is increasing. And since one of them is changing, that means the other one has to stay constant. Potential energy has to stay constant. You can't have kinetic and potential changing. Only one of them can change. D, if it's temperature constant, potential energy stays constant. Kinetic energy, well, no, I mean potential energy increases, and kinetic energy constant, since there's no change in temperature. Okay, so in this case, let's see, from 0 minute to 1 minute. So 0 minute and 1 minute. temperature is decreasing. So there is a change in temperature. If there's a decrease in temperature, they're saying potential energy. If temperature is changing, that means kinetic energy goes down. Since kinetic energy is changing, that means the potential energy has to stay quiet. It has to stay constant. Okay, so in this case, in 0 minutes, 1 minute, the potential energy remains the same. Okay, how about the potential energy between 10 minutes and 15 minutes? Okay, 10 minutes, 15 minutes. There's no change in temperature. So what does that mean? Kinetic energy stays constant. We're not moving the kinetic energy since there's no temperature change. However, the potential energy will change. But are we going to go down or up? We're going down. It's a cooling curve, right? It's a cooling curve. So obviously, potential energy will decrease. Okay. Why? Because kinetic energy didn't change, but we have to change one of them. So potential energy will be the one changing. How about part C? What happens to the kinetic energy between 20 and 22 minutes? So between 20 and 22 over here. Okay, what happens to the kinetic energy? Since the temperature is going down, that means the kinetic energy is decreasing. And potential energy, they didn't ask it, but potential energy will stay constant. Question 14. When the body of a liquid evaporates, only its fastest molecules have enough kinetic energy to overcome the attraction. The molecules that remain have less kinetic energy, so that has a lower temperature. Okay, yep. Let me explain. Uh, let's say you're boiling water. Okay, this is your gauze. Yeah, you're boiling water and you put your I don't know, your pan. What do you say? What do you call this? طنجرة. I don't know. عارف كيف يقال طنجرة. Uh, pot. صح pot. Uh, so you put water in it, yeah, and you want to boil it. So how this happens or how it evaporates, you're heating this pot up. So you're transferring some temperature to it. You're transferring some thermal energy, right? So obviously the temperature of the liquid will start increasing. Okay, the temperature will increase, therefore the kinetic energy is increasing, right? So we're starting to move. You're going to start seeing movement in the water molecules. Look here. Does the whole liquid evaporate at the same time? No, خلاص, you snap your fingers, everything boiled? Obviously not, right? So only at the surface of the liquid, the water escaped and goes up. Did you ever see, water evaporating from the bottom of the pot? Obviously not, right? It's always at the surface. Why is it at the surface? Because at the surface they have the highest kinetic energy. The ones at the bottom, they're trying to be like the water molecules at the top. They're trying to gain energy. They want to be like the ones at the top. But it takes them more time since they're all the way at the bottom. So the ones at the top have the highest kinetic energy. So those are the ones that evaporate first. Okay? They evaporate first since they have the highest kinetic energy. But the ones at the bottom they have lower kinetic energy. What does it mean if I have lower kinetic energy? That means I have a lower temperature. What does it mean if I have a lower temperature? That means I'm colder. Okay? So let's see here. When it evaporates, only its fastest molecules have enough kinetic energy. The ones at the top are the fastest ones. They have the highest kinetic energy. Okay. So why do the ones with high energy evaporate and the low energies don't evaporate? Because you need energy to separate the water. They have bonds together. Okay, they have bonds, water bonds. They have molecular bonds. To separate it, you need energy to go up and خلاص, you evaporate. We need enough kinetic energy to overcome the attraction. Okay, the molecules that remain in the liquid have less, so the ones that stay are the ones at the bottom. They have less energy, and since they have less kinetic energy, that body of the liquid has the lower temperature. Question 15. Okay, what is this phenomenon? Okay, diffusion. I think everybody knows this. Okay, you have molecules like this. Here's a high concentration. Here's also high concentration. So obviously it's gonna go from high concentration to low concentration, and this will go from high concentration to low concentration, and it's gonna be evenly mixed out. I just explained that. Okay, for those who don't take bio, diffusion is always high concentration to low concentration. This wasn't mentioned in class, but no, this is just a way to recognize when you have diffusion. So these will go from where there's a lot of them, it's going to go to the lower concentration, and these ones where they have high, it's going to go down here to the lower until it's evenly spread out over here. Okay, so this is diffusion. What state of matter in which this phenomenon occurs the fastest? Obviously gas. know, you don't see a solid diffusing fast or a liquid diffusing fast. It's always the fastest in gases. Uh, Question 16. Okay. Uh, a whipped cream charge is a metal cylinder filled with N2O gas. The volume is 10 cm cube and it contains 0.18 mole. Use R is 8.3, and they're saying the temperature is 300 Kelvin. They want you to find the pressure. Again, يعني we have volume, we have moles, we have, which is N, we have R, we have temperature. They want pressure. Akid we're going to use PV equals nRT. So let's apply it. So pressure times the volume, which is going to be 0.01. Why? Because this has to be in dm cube, right? You can't use it as cm cube, so you have to divide by 1000 and you get 0.01. 0.0, yeah, equals the moles, which is 0.18, times R, which is 8.3, times the temperature 300, and you're gonna end up getting, I think, let me do it on my calculator. Okay, correction. I was solving wrong. Apparently, when using PV equals nRT, your volume has to be in meter cube and not dm cube, because it's physics, not chemistry. In chemistry, you use dm cube. Here also, yani, depending on what they're asking. Like, let me see. Was I think it was the volume? Yeah, if they're saying, and if it's both liters, there's nothing to convert. Here, Charles' law. Again, if they're both liters, there's nothing to convert. But yani, apparently, if you're using PV equals nRT, you're just using PV equals nRT, the volume has to be in meter cube. If you're just doing PV equals nRT, and to convert from centimeter cube to meter cube, you have to divide by a million. From centimeter cube to meter cube, I think this is the first time you use this conversion factor. You divide by 1 million. 2, 3, 4, 5, 6. Or you could just do divide by 10 power 6. Whatever you want. So 10, you could just say 10 times 10 to the power of negative 6. Or, which is the same as saying 10 to the power of negative 5. Because I'm not going to put 0.00001. Yeah, that's it. If you want to use this, whatever. But this is the volume we're going to use. The pressure times, let's say 10 to the power of negative 5, because it's 5 zeros, equals 0.18 times 8.3 times 300. You're going to end up getting the pressure is equal to 1, 2, 3, 4, 5, 6. You're going to get a big number. You're going to get 448200000. 1, 2. Okay, you're going to get this number. Okay, but they want it in megapascals. Megapascals means in your answer, divide by 10 to the power of 6 or divide by 1 million. And once you do that, you're going to get 44.82 megapascals. And they're saying one decimal place, so just 44.8. Question 17. I think 17 was easy. The modern can hold beverages up to 600 kilopascals. Assume the pressure of the gas is 20. Assume the pressure of the gas in the 20 degrees is 300. Then how much? Yani, what's the temperature at which the can will burst? Okay, at which the can will burst. Yani, basically what they're saying is the can hold up to 600. So the maximum is 600. After 600, it's gonna pop. Okay, they're saying assume that when it's 20 degrees, the pressure is 300. So what will the temperature be when the can will burst? And what will the temperature be when the can will burst? The pressure is 600 because they're saying it's up to 600. That's like the maximum. Okay, المهم, you can do again P1 V1 equals nRT1, or P2V and then P2V2 equals nRT2. Like in chemistry, cancel moles with moles because it's not mentioned. R always cancels with R. And so since we're saying the amount of gas is constant, yani the volume. Amount yani volume. So you cancel the volume. So P1 over P2 equals T1 over T2. So pressure 1 is 300. Pressure 2 is 600. Temperature 1 If you put 20 degrees Celsius, you're gonna get it wrong. Why? It's very important to understand the temperature is always has to be in Kelvin. Okay, and you know, to convert to Kelvin, like in chemistry, you do plus 273. For 20 plus 273, the temperature is 293. Over T2, cross multiply, and I think you get 500. You get T2 is 586 Kelvin, but they want it in degrees Celsius. You have to, that's a 5, huh? You have to subtract by 273, and you're gonna get 313 degrees Celsius. Okay, well, we're not done, so let's do the grids. Page 30. Was it 120? Yeah, this one. A spring has an original. Okay. I think the answer in the exam was 25, but let's solve this. A spring has an original length of 20. When a load of 300 is applied, it produces extension of 50. What will the length be when 240 grams is applied? Okay, for this question, and it comes the exact same in the exam, what you can do is you can do mass 1 over delta L equals mass 2 over delta L2. Okay, delta L1, delta. Okay, so what do I mean? So 300 grams, I can put it over 50 millimeters. And then mass 2, I can put 240 grams over x millimeters, yeah? If you cross multiply, let me do it on my calculator. 50 times 240 divided by 300, you get x equals 40 millimeters. That's delta L, right? So delta L is 40 millimeters. So that means it's gonna extend, the spring is gonna extend, so this is the spring. Okay, once we apply 240 grams, it's gonna extend 40 millimeters. So what will the length be if the original length is 20 centimeters, yeah? Add that 40 millimeters, so 20 centimeters plus 40 millimeters, it's gonna be 24 centimeters. What happened? Is it 20 plus 40, 60? No, look, it's centimeters here and it's millimeters here. Okay, you can't add centimeters and millimeters. If I convert this to centimeters, 40 millimeters, it's actually 4 centimeters. So 20 centimeters plus 4 centimeters equals 24 centimeters. Because from millimeter to centimeter, بتقسمها 10, you divide by 10. Okay, so you get your final answer 24. In the exam, just do this, and then whatever answer you get, just add it to your original length. That's literally it. Okay, and if I'm not wrong, the answer was 25. Don't take my word for it, but if you see 25, I think that was correct. Wait, no, I think it was 17.5. Wait, let me see. My fault. The answer in the exam was 17.5. I checked the paper. It's 17.5 in the exam. If you want to memorize it, memorize it. But يعني, I don't know. I just think. Okay, question 14. This is the second one required. What is the magnitude and direction of the resultant? Okay, you have, it's very easy. You have f1x, you need to find f2x, you need to find f3x. بعدين بدك تلاقي f1y, f2y, and f3y. f1x, obviously, it's 12. It's given, 12. Since it's directly to the right, it's 12. If you want to prove it and act like a smartass, the angle is 0, so you do 12 times cosine 0 since it's fx, which is 12. But bro يعني مبين 12, it's obvious. المهم f2x, again, it's obvious, it's 0 since it's on the y-axis. It's 0. Again, if you want to prove it, you can do 9 cosine 90, because it's always cosine for fx, right? And you're gonna get 0. Again, it's obvious, it's 9. It's obvious it's 0 because it's on the y-axis. There's no x, it's on the y-axis. Okay, f3x, this one you actually have to use the formula. أول شيء, it's to the left, so it's negative 15 times cosine 53.1. Let me do this on my calculator. Negative 15 cosine 53.1. You get negative 9. Negative 9. Okay, f1y, again, it's obvious it's 0. If you want to prove it, 12 sine 0. You get 0. f2y, you get, it's 9. If you want to prove it, it's 9 sine 90, which is 9. And it's acting vertically upwards, so it's obvious. f3y, it's going upwards, so it's positive. 15, but this time sine 53.1. And you get 15 sine 53.1. You get 12, approximately 12. Let's just say 12. هلا you have to add them up. The total fx is going to be 12 plus 0 minus 9, which is 12 minus 9, which is 3. And the total fy is going to be 0 plus 9 plus 12, which is 21 newtons. They want the magnitude. So they want the magnitude of the resultant. So you have to do radical fx squared plus radical fy squared. So 3 squared plus 21 squared. And you get radical 3 squared plus 21 squared. Hold up. 21.2, and I got 21.2. Direction, I think they want the angle. How do you find the angle? Remember, the angle for any resultant force is shift tan of شو اسمه the y vertical over horizontal. So 21 over 3. 81.9 degrees. Okay, let me check these answers. أنا شاكك بالوضع. Hold up. Question. What question is this? 93. Okay, 21 and the, oh, hold up. Yeah, 21.2 and 81.9 degrees. Yeah, okay. For 81.9 degrees and 21.2. So we got it correct. That's it for question 14. Okay, the next question is question 179, which is page 750. You're probably saying, طب وليد, this question 2, it's the number beside. Not probably, but if you said, what are the tiniest particles of matter? Atoms. That's it. 184, page 50. 184. Okay, in an experiment to observe Brownian motion, an IGCSE student watches a brightly lit smoke particle moving around in air. Why can't the student see the air molecules moving around, and why is the smoke particle moving around in air? Okay, أول شيء we said, why can't the student see the air molecules moving? Molecules moving, what's that? We said that's molecular motion. The actual molecules moving. Can we see it? No, we said it's hypothetical. It's a theoretical proof, right? It's a theoretical theory. Okay, and no, it's not proved. Why can't he see it? Because it's too small. Remember, I told you guys over here, the atoms here, they're too small. The molecules are too small. So the molecular motion is theoretical because they're too small. Here, why can't he see the air molecules? Because simply they're too small. Oh Allah, I have to go down. Yeah, here. Whoa, where'd I go? I think it's here. Yeah, the air molecules are too small to be observed. And then for part B, why is the smoke particle moving? So why are the particles moving? Okay, they're moving due to the collisions of the air particles. Okay, yeah. I don't know if I explained, but for Brownian motion, why these are moving? Obviously, it's random motion, but it's because it's moving because of the molecular motion, right? So we needed a reason to say that this Brownian motion occurs. Why? Because of the molecular motion. And the molecular motion is the particles, the atoms, and the atoms that are moving. For those atoms that are moving causes this smoke particle to move around, if you get what I mean. They're colliding with the particles that are around to move. أكيد this is gonna come multiple choice بس يعني just to help you understand. 197 page 52. Okay, yeah, this one's a good one. A gas occupies a volume of 250 cm3 when its temperature is 20, and its atmospheric pressure is 760. Calculate the volume of 35 degrees and pressure of 770. Okay, they didn't. Okay, so we have more than one thing changing. Okay, we have more than one thing changing. We have pressure, volume, and temperature changing. Let's do it. P1 V1 equals nRT1. P2 V2 nRT2 cancel. R with R and with N. But pressure is changing, volume changing, temperature is changing. So you're gonna get P1 V1 over P2 V2 equals T1 over T2. Okay, let's do it. Obviously they have to be in the correct units, yeah? Pressure 1, it's in 760 mm, this one's in 770. Since they're both in mmHg, يا أخي خلاص, you can keep it, okay? So 760 over 770. 770. hold up. 770. Okay, 760 times V1, volume 1. Volume 1 was 250 cm cube. Do they want the answer in meter cube? Hold up. 197. No, they want it in centimeter cube. Okay. Fine. Let's just solve using centimeter cube. They've solved using centimeter cube. Obviously, and I'll tell you to solve differently. Volume 2, we don't know, right? Because we're trying to calculate the volume, the new volume. We don't know what we're trying to calculate it. So let's just keep it x. Okay, T1 is 20 degrees Celsius. But can we use this 20 degrees Celsius? No, you can't. So you have to do plus 273. It will be 293 over T2, which is 35 degrees Celsius. Change it to Kelvin is going to be 308. Wait, hold up. What, 50? Yeah, 308. So let's cross multiply. And you're going to end up getting x equals, hold up, x equals, I got x equals 259.4 cm cube. I have no idea how they got 260 unless they rounded it. Maybe they rounded it. Yeah, two, as long three significant figures. Yeah, if you were to round it to three significant figures of, it won't. Yeah, they rounded it to two significant figures. This is something the Sabbath curriculum doesn't teach, but sometimes 259.4. If you want to round it to two significant figures, okay, you only look here. You look at the second and third significant figures. So if you were to round it here, 259 becomes 260, and they don't count the zero as a significant figure. That's part of the IGCSE curriculum. It's not part of Sabbath. If you're doing IGCSEs, you know what I mean. But it's I don't know. المهم, you get 259, 260, whatever. They won't they probably won't count as significant figures. It's gonna be multiple maybe. I don't know, inshallah. Moving on. 197, 199, صح? 190, 198, 199. Okay, في 198. An ideal gas is kept at a constant temperature. Initially, the gas occupied a volume of 4 liters. If the pressure is doubled, what would the volume be? Okay, أول شيء, there are some rules you need to know, okay? Like, pressure is directly proportional to temperature, volume is directly proportional to temperature, but pressure is inversely proportional to volume. Pressure and volume are inversely proportional. That's why I say 1 over. What's an easy way to know this? I know how I memorized it. PV equals nRT. If you're on the same side, that means you're inversely proportional. If you're on the opposite sides, that means you're directly proportional. So since volume and temperature are on opposite sides, I say they're directly proportional. Well, since pressure and temperature are on opposite sides, I also say they're directly proportional. But since pressure and volume are on the same side, they are inversely proportional. So over here, since we're talking about pressure and volume, pressure is inversely proportional to volume. So if pressure is doubling, if this is doing times 2, this is always 1 over the 1 over. So this is times 2. It's always the opposite. What's the opposite of doubling? It's halving. So it's times 1 over 2. So 4, what will happen to the 4? It's going to half. So it's going to become 2.0 liter. The last one, it's not, I don't think it's the last one. Is the last one? Oh, there's 2 more. Okay, 199. The pressure in a sealed can is 350 when it sits at room temperature. If the can is heated to 48, what will the new pressure be? Okay, you can do it the same way. These are the same ones as the quiz. nRT1, P2 V2 equals nRT2. Okay, N and R, you cancel them. Okay, we're talking about pressure and temperature. It's a sealed can of gas, so the volume isn't really changing. So we cancel out the volume. So P1 over P2, T1 over T2. Pressure 1 is 350. P2 we don't know, right? We want a new pressure. We don't know. T1 is 25 degrees. But you have to change it to Kelvin. So 25 plus 273 will be 298. Over the new temperature, which is 48, but you need 2 plus 273. And you get 3451. 321 degrees. Cross multiply 321 times 350 divided by 298. You get 377. So P2 equals 377 kPa. Okay, is that correct? Yeah. Okay, question 200. Last one. A gas has a volume 12 liters and temperature 410. It's heated to 500. Find the volume. Okay, easy. Again, P1 V1 equals nRT1. P2 V2 equals nRT2. N and N, R with R. Okay. Since pressure is constant, P with P, you cancel. V1 over V2 equals T1 over T2. Volume 1 is 12. Volume 2, we don't know it, right? We want the volume. Find the volume. Equals T1 410. It's already given in Kelvin over 500 T2. 500 times 12 divided by 410. You get 14.6. V2 equals 14.6. Is that correct? Yeah, 14.6 liters. That's it for this Physics AMS. Thank you so much for watching, and good luck. I hope you do good.